thanks for that introduction. So today we're going to share our journey of like how the machine learning stack is scaled in a large organization. So we're a large and complex organization operating in over 180 countries, and we also have quite a big R&D team based in Iran, which some of our colleagues are also here. So feel free to get in touch after the session to know more about the local activities as well. So just jumping right in, so scaling reproducible machine learning stack that is cloud native. So as with any large organization, generating value from data is a long journey because building a machine learning model never happens in isolation, and you need to embed it in the business context to get the value of it, right? So a lot of effort, if I take the survey as a reference, more than 40% of the effort is spent on the data collection, standardization. So that is a bit of grunt work that we would like to offload from the data scientists and the ML practitioners. And machine learning code is often only the visible tip of the iceberg. So meaning, it needs to be supported by a complex piece of infrastructure, ranging from monitoring or serving to be able to deploy those models. Okay, so machine learning is hard. By that, I mean not necessarily developing the model itself, but okay, so if you see like one of this, my favorite codes, so it took me 3 weeks to develop the model, but it's been 11 months and it's still not deployed. So that sort of hits home maybe for some of you who encountered similar situations, right? And the complexity comes from the interfacing with the business systems, and okay, you need to make sure that you have reproducible workflows. And the journey doesn't end there. So we have black swan events like COVID-19 or like other the natural course of events in the business that also drifts the machine learning models. So meaning you need to also keep close tabs on your models and monitor them, monitor the drift, and be able to improvise from time to time. So with that in mind, so we set out to create a cloud-native workflow that we call FIRE. So which stands for flexible, inspection-ready, reproducible, and easy to use. So by flexible, I mean so when you have a diverse range of structured and unstructured data and a lot of distributed teams like working on a common data platform, so it should be scalable. So you need to have the infrastructure that scales to the requirements of different teams, and it should adapt to the needs of every single user. And most importantly, inspection ready. So you've got to have the workflow where each artifact is reproducible and inspectable from time to time. And so speaking of reproducibility, portability is another important angle that needs to be supported so that the work that you do in a development environment can be easily lifted and shifted to the production environments. And also, while ensuring all of that, it should be easy to use, and this could be done with more composable designs. And so we should also enable the frictionless experience for all the users of the platform. And you know what's really good at scalable, all three of these aspects, in general, Kubernetes and containers. However, so you've got to know a little bit more than just the containers. So there are all these other complex layers that often acts the overhead for the practitioners, and which is often getting in the way of faster route to production. So we try to take a fresh look at this and learning from different projects that happen in the organization. And we create something called the DSLite Workbench, which is our data platform, or data science platform. So for being more specific, to bridge the gap for scaling machine learning experimentation. So in a nutshell, what's it about? So the Workbench is a self-service platform that gives you access to infrastructure that is fast, lightweight, and fully automated. So for instance, there are a lot of data sources across the country that needs to be readily accessible, and it should be done in a safe and secure manner. So when you're also collaborating with external vendors, and there's a need of sharing sensitive or privacy-sensitive data, so that's so collaboration and access to data is paramount. And so the workbench provides you access to different kinds of analytical tooling and the IDEs and notebooks, things like that. And so we have components like EMR and SageMaker that we leverage on to specifically scale the compute and the storage aspects. And it is tightly integrated with our CI/CD and the MLOps tooling to support much faster route to production. And this tooling is standardized, which my colleague will talk about in a bit, and it's used by a number of teams and data scientists, statisticians, ML engineers across the country.
So it's on top of AWS, I'm sorry to interrupt.
So we are AWS house, but yeah, it's on top of AWS, and there's a lot of other custom toolings and integrations that are specific to the organization.
I'll go into this.
Yeah, so we have a separate section planned for that. So a little bit about the project workspaces itself. So if you look here, so each workspace is standardized in a way that it is consistently repeatable and scalable, and it is isolated, meaning every user of the workspace gets a certain set of standardized tooling within their workspace. And each workspace is then integrated to the project-specific integration. So meaning everybody has the consistent set of access to the raw data. So we consider the raw data as immutable. So meaning any workflow that you build on top of the raw data should be completely programmatic and automated, so that you can easily move it to production. So it's integrated with a set of scheduling tools like Airflow, or CI/CD tools like Jenkins, and monitoring tools like Prometheus, and all of this runs on Kubernetes. So from the user point of view, if you're setting up to start a new project, so we have a very simplified workflow. So we measure in the sense of the time it takes for you to get access to the data and set up a workspace, and how fast can we do it, and how fast can we enable a new project to start exploring. So typically it starts with creation of a specific identity role for each project. And so Leandro will talk more about the automation behind the scenes, which creates a whole bunch of infrastructure that is integrated with the projects. And the people who are part of the projects, they can request access to specific data sources from our wider data platform. And once these data sources are mapped to your project, as a data scientist, you're pretty much ready to go and start focusing on the work. And so we call it the one-click infra provisioning. So we have several ways to provide infra. So there are different portals that can help you create both on-demand infrastructure. So that suits your project. So for instance, we have EMR clusters. So you could create compute-intensive or memory-intensive clusters, or also set up your workspaces based on the resource requirements that suits your project. And likewise, all of this could also be orchestrated programmatically through components like Airflow and Schedule. So a bit about the workbench and the tooling. So these are some of the screenshots, so just to give you a bit of the flavor of how things work at the user level. So the workspace is a collection of development tools. So often when you're working on the data science project, you might start with exploring the data in popular notebook tools like Jupyter, but then as you mature and evolve to the next stage of the project, so you need to write more production-ready code, and you need to be able to transfer that work from the notebooks to the IDE. So we also use Visual Studio Core and provide other tools like Studio and remote access. And all of this is integrated to the underlying storage and compute, so which I'll show. So there are different aspects of compute scaling. So one of the main components that we use for compute scaling is the AWS SageMaker. And AWS SageMaker, so we use it in a very specific context. So we leverage on the SageMaker SDK, which provides us an easy way of spinning up and launch new training workloads. For instance, here I have an example. Let's say if you got a script or a bunch of dependencies that helps you, which is your training code, and you could launch the training code on the instance of your choice. So if your workload requires maybe multiple GPUs, and so you could start small and scale your machine learning workload more than one GPU. So it makes it easy to not only have the instant compute power for whatever your ML workload needs are, but also optimize for the cost. So these instances are not running all the time, so they're available to you like whenever you need it, but then they're automatically built. So we don't spend too much money on the expensive users. And similarly, so I mentioned like cloud IDEs, so it's important to have all the cloud native IDEs, so that is integrated with the remote development environments. And so similarly, on-demand EMR clusters that I mentioned, so this is what we specifically use for scaling the data processing or the feature engineering aspects of the ML pipelines. And another important piece of component that we also tightly leverage on is for especially in the context of collaborative experimentation and to enable end-to-end reproducibility. So model lifecycle management is an important aspect of that. So we use open source component called MLflow. So it helps you track experiments and also like versioning models. And so let's say if you're running ML workloads and collaborating like within a team, and you're doing multiple parameter tunings, so you'd like to have that version history completely tracked and also model binaries, specifically version for release to staging or production. So yeah, and all of these components are again tied together through a string of APIs and also be able to connect through our workflows. So I'll pass on the mic to Leandro, so who will share a bit more of how these tools are actually connected with the more complex underlying infrastructure.
Hi guys, my name is Leandro. I am the platform engineering lead for the data science stack on PMI. I'll be leading you a little bit around the challenges building up all that Dinesh was mentioning about and going a little bit about the technology that is under the hood, so answering many of your questions. Okay, so let's dive right in. I will focus here. Okay, so I'm exaggerating, of course. We didn't used to have like these 386 machines. I'm probably sure, looking at the audience, many of you never even saw one of these things in real life. But what we had previously as a data science platform in PMI was a Hadoop cluster that was managed via Bari, and it was sitting on top of classic EC2 instances, right? So it was one cluster for all the data science projects in PMI. So we were also giving these kind of DS labs for our data scientists. These are EC2 machines where with Docker there, the data scientists will get one per project, and all data scientists in a project will go SSH into the machine and throw their compute to the cluster and wait for the results. And that's how data scientists were working. I'm guessing you can see the flaws here, but there was a really big problem with the scaling of this. It was one cluster for everyone. There was a lot of starvation for resources. So if people was not careful enough, someone would take the whole cluster and no one would work. Starvation also inside the EC2 instances, because many data scientists, one instance, someone takes all the memory, no one can work. So come 2019, PMI organized this hackathon for the data platform. So all data-related people got together in Krakow, in Poland. And the basic idea was 2 days, develop an idea, present it, and show it to the world, and you were getting the possibility to implement. So Dinesh was the winner. He came up with this DS-like idea, and part of his prize was working with my team to build this app. Pretty nice privilege, if I may say so. So basically, the answer that we come to this problem of scaling was compose our infrastructure. Pretty big work, but in the end, it's infrastructure that is developed, that it's deployed quickly, that it's highly reliable, and that it's consistent. So, deep diving a little bit more on the platform, already Dinesh kind of mentioned a little bit of this, but I go a little bit more in depth. To answer your question, our platform is AWS based. It was born in AWS, meaning that it's cloud native, but we do use a lot of the managed services. Dinesh already went through EMR, SageMaker, and under the hood we have a whole lot of things. I will go over them. But we also take a little bit of pride in using a lot of open source software. And I'm really bothering my team a lot, and they actually come forward, and we are actually collaborating with some of these projects. We are dropping pull requests to them, fixing some bugs that they're having that are bothering us, or at least just dropping issues for them to fix. So this is, I think, very important. It's part of giving back to the community also through our day-to-day show, right? And besides this, we also have some in-house developments. We are mainly DevOps in my team, and most of us are maybe more close to operations than development. But we manage. We provide these kind of self-service portals. I will go over them a little bit. And okay, so just to mention, if you guys are curious what all these pretty logos are, we are using the Prometheus Grafana stack for monitoring of our platform. The data scientists are able to create their own monitoring dashboards there. Everything that is logging is going to OpenSearch. OpenSearch is the evolution of the ELK stack. That is, it break apart, now it's OpenSearch. We have Artifactory for our Docker registry, for our Python repository as well. Everything that I mentioned, in the end, is going to Kubernetes. Kubernetes, it's an orchestration of containers, so everything is in the end containers. And this is why we provide lots of this tooling for the creation and maintaining and monitoring of these containers. So we provide Jenkins, we provide Airflow, we have vulnerability scans with Aqua, we provide HashiCorp bot for secret keeping, so trying to avoid hard coding. This is really important and really not secure. We have SonarQube to monitor code quality. We provide Apache Airflow so that the guys are able to go ahead and schedule their workloads. So all this is in the end supporting the DS Lite that is for data exploration and the going to production of our products. One really nifty little thing and nice that we have is this SIG in the middle. It's Seldom Core. This is a Kubernetes operator that with some help of our own development, with one click, the data scientists are able to deploy an API that goes and consults the models that are stored in Everflow and gives you results. This is really cool and it's one click. Dinesh maybe can go about it in the question and answer if you guys have any questions. And also now I will be going a little bit in deep into the how we get to this. There are lots and lots of technical details that I will not go on about, but if any of you guys are curious, just ask me or come to me after the session and we can discuss. I know it's a data conference, so maybe not many people interested, but maybe some are. Okay. So the way for us to go ahead and do this platform, because as you see, it's a lot of things going around, and we are a team of 6. We are not unlimited. So the key for this is automation. All along the way, every layer that on our platform is automated. And we really put a very conscious effort that everything that we do is code-based. Try not to do anything manually, because then is where problems appear. If you have to redeploy something, oh, but this guy went ahead and created a text file here. No, not the way to do it. So yeah, we're going with this really code-based infrastructure. So the output of our daily shop, it's a bunch of code that we deploy to Bitbucket. Bitbucket is the PMI source control version, source control for code. You could use GitHub, GitLab, whatever. And this then goes to our automation tools that, depending on the stage and what it's needing, it's one of these, or maybe some that it's not here, so either Terraform, Jenkins, Flask, that is a component that deploys manifest to Kubernetes. And then it reaches the cloud or our environments. We provide 3 environments for data scientists to play on: development, quality, and production. And there is a nice thing going around here. It's for the most part automations that deploy automations that deploy automations. So it's mainly Terraform at the beginning that is deploying all the things. Then Terraform deploys Flask. That Flask goes and checks everything that goes to Kubernetes and deploys it to Kubernetes. So it deploys the Jenkins, for example, or all the tools, and then these things start to work to help with the next automation. It's a really cool site. I'll deep dive a little bit into these different layers I've been talking about. I will talk about the base infrastructure deployment for our platform. We use Terraform for this. We deploy the baseline for the networking, so I'm going to be very AWS specific here, but in the end it's networking components mostly. So all the VPCs, the subnets, the root tables, internet gateways, NAT gateways. We also are a little bit, we are a big corporation. Data leaks are a big problem. Every time that we design something, it's from the inception, it's security oriented. Security is in all the process. Believe me, in the past it was done as an afterthought after everything was deployed and everything was really hard to manage. So this is what we are doing from the beginning. We don't have open internet access, but we have an AWS firewall with whitelisted domains that we agree with the data scientists. We have WAF to protect us from cross-site scripting, from denial of services. We manage our domains with Route 53. Afterwards, when all the networking and the base is there, we deploy our Kubernetes stuff. We use the managed service that is EKS. We deploy some configurations for this EKS, so some add-ons, some configuration stuff, and these kind of things. And we deploy this thing that is Calico. Calico is like the internal networkings because the AWS provider that didn't quite make it for us. If you are curious, then come talk to me. And we deploy some other stuff to help with the deployment of everything else. So some storage solutions like EFS, S3 buckets, databases for the backend, and this kind of stuff. So next layer of this is all the resources that the data science projects actually end up using. From a platform point of view, that the new data science project is born means that there is a new group in Active Directory. So we are monitoring Active Directory for new groups constantly. Whenever we see there is something new, Jenkins picks up and go and deploy a whole bunch of stuff for this kind of projects. So deploy all the policies and all the databases, the data buckets, Athena for querying. We set up repositories for the data scientists to be able to kind of go deploy the code. We create a vault space for the secrets, a lot of Kubernetes resources, so the namespaces for them, the security aspects, the network aspects, and these kind of things. Moving along a little bit, we have the self-service portals as well that Dinesh was talking about. This could easily be, some of them at least, be deployed at creation time, like the other things. But these things are costing money and are not necessarily used by every data science project. Some may use it, some may not. So our job actually is to be as transparent to them as possible, and the other way around too, so they don't bother us too much. So the idea is they can go ahead and provision anything that they want by themselves without needing to request anything. Same goes for all the integrations with all the things that I've been talking about. they don't be needing to request approval, request permissions to use these resources. No, everything with the mentioned security underneath and making sure everything is isolated, but they can go ahead and just use without doing much or needing to request permissions or anything. So about these self-service portals, we have what this slide is kind of the start is our data exploration tool. But we were also provisioning, let them auto-provision EMR clusters to do all the compute. If they know they are going to have ML models and trainings, they can deploy the MLflow server. Same with Airflow, that is for scheduling. They can also control the Kubernetes spots. We are a little bit picky here. We don't give kubectl access to our Kubernetes clusters. So to make up for this, we let them, with the portal, control their pods, be able to kill them and this kind of stuff. So that's it about the platform under the hood. I'll leave you now with the very capable hands of my colleague Rikard, who will be talking a little bit more about the aspect.
Thank you very much. So my name is Rikard Sandstroem, and I'm the head of Advanced Analytics Center of Excellence at the Filipino. So I'm going to talk a little bit about how we are using this to drive a community of users. How we can actually use this to make our company better. So first of all, we sort of coming from a traditional structure like this, where like a functional structure where, say, all the finance people, they're sitting in the finance function, and in that one you have, your audit function, for example. Same thing like that for, say, data scientists, function, they belong to IT, just like InfoSec, but since we have different interests than InfoSec, we sort of split groups, all reporting to our CTO. Now, this is great in a sense because we can have all these people who know their topic, they can talk to each other because they're like in the same office. However, the problem is sometimes other people actually want to do something which maybe there's some need from finance actually to do some data science themselves, and then they need to come and talk to us, asking for our help, and that's a bit inefficient. So one thing that we are moving towards now is to have like this product-based organization where we have like our senior management team just like before, and then we have like this different product verticals. So we have every sort of product division is essentially like a self-contained business in a sense. And that means that they all need to have all this, you need to have like auditors and data scientists and InfoSec, etc. in every such product vertical. And then you have the opposite problem that how can you sort of make sure that the data scientists, don't do things completely different in different parts of the company. I'm sure that auditors they have like always two different ways of doing everything, and if everyone decides to do differently, it's going to be a nightmare, right? So for this reason, we need to create a number of such centers of excellence, and that's the one that I'm leading for Advanced Analytics. So I'm going to discuss a bit more about this, right? So having this sort of decentralized approach, we have more like hub and spoke approach. So we then become the hub for the Advanced Analytics. And then we have this sort of solar model, right? So we have the different regions, like this gas giant, and then we have different markets who belong to these gas giants. Then we primarily discuss, these regions that have specific problems that other regions don't, like EU legislation, how you can do your analysis, what data you're allowed to collect. Then we're also talking to, like the, sort of more like sort of functional groups still, like the product teams, so if we have IPOS, then they still have like different sort of sub-teams in there, but then we more focused towards, discussing more with this
gas giants and let them sort out the more details. Similarly, we also have, for example, our life science function that Dinesh can talk to you more about. As you might have heard, we also like gearing up more in the producing products which are beyond nicotine, so like entirely nicotine-free products. So that it goes more into like a more healthcare direction. So if you're interested, you can follow the link here on the slide later. We'll take you to like one of the press releases that discusses this more in detail. But last but not least, we are not the only sort of star in this galaxy. Right? We have a lot of other centers of excellence. So if we have something we need to sort out with data engineering or with data management, we go and talk to their centers of excellence. So ultimately, the company becomes like a galaxy. Right? So what do we actually do offer to the different spokes? For people, we assist in talent acquisition and hiring. So we actually help in interviewing candidates, helping them, set some sort of standards for what kind of skill sets do we expect if someone's supposed to be like senior data scientist. We also provide training and upskilling of all the people who want to use the, become data scientists or become better. So we of course using like external providers like Coursera, eCloud Guru, that sort of thing for more generic things. But some of the things are very specific to our functions, and then we deliver these things also. In terms of like processes, we are responsible for defining what are the best practices, but that's also like a dialogue, right? So we also learn from the spokes about how they are doing things. If they have a better way of doing it, then we say, okay, actually that's a great idea. Let's disseminate that. Make it part of our training, and everyone can benefit. And also, we do promote actively people to actually use the right tools that we think are right for the job, and that means that we also do quite a bit of technology scouting to make sure that we're always up to speed with this very fast-changing landscape in data analytics. For technology, as we have DS Lite, which is our common platform that we're using for prototyping primarily. And also, one of the big bottlenecks that if you're an analyst, you might have a problem even just knowing what data is available already, and also how to get access to this data. And our solution to this is to have this data ocean that provides easy access to this data. So currently, who's actually using DS Lite? This is maybe a month old, and as you can see, we have a pretty strong. Sorry. Thank you. We have a pretty strong growth trajectory, as you can see. So I'm going to try to use this. That's okay. So over time, we've been going quite fast, and as you can see in the beginning, we were primarily EAD, that's really us, like in the hub, so to speak. But with time, we are now actually the smallest group of people. Most people are, sitting in the spokes, like worldwide. We have, a month ago, we have about 223 users. I think it's a bit more now, spread across 46 different organizations. And last I checked, we have 48 projects running in parallel. So, we are expecting this to grow to something closer to 500 before year end. So, this also pushes, this is also part of what's driving us to make some of the changes, because just like Leandro, I cannot scale my team infinitely. So, how do we organize ourselves for scale? So one thing is to, make things as self-service as possible, and that means we have a lot of documentation, we're providing a lot of trainings in order to make people more efficient at doing their work without they have to talk to one of my direct reports. Another part, it's like this sort of self-service, like I mentioned. So traditionally in the beginning, if you wanted to use a DS-like lab, well, you need to talk to me, and I have to request it for you, and then Leandro's process triggers. But what if I'm on a conference like this? Then nothing happens. So for this reason, we're also like rolling out this more self-service, and just you go to your essentially like your shopping cart, and you just say, yeah, I want another lab tech, and you get it. Also, another part which we want to do a bit more organized is like often people are coming to me or other people like Dinesh with great ideas about the analysis they want to do. And that's a lot of meetings and email exchanges, etc. And again, it's not scalable. So for this reason, we create this sort of demand pipeline so people can fill in forms, and then it gets automatically, triaged to the people who need to follow up. And we can also have actual metrics tracking. How long time does it take for us before someone has an idea about doing something, and to actually start interacting with them and see if we can address it. And then also we are tracking all the costs, usage, and the benefits of what we actually are doing, because this is, it's also like a motivation. Why do we even exist, right? So if there's no benefit, it costs us a lot of money, that might be a hard sell. So this is also important to have that like tracking metrics to what we do. So some of the areas where we are engaged in, as you can see, we're not really specialized in one particular area. We have individuals who are more specialized in one area, but we have projects in things like computer vision, natural language processing, of course, but also things like fraud prevention. We're a big company, and a lot of people try to steal money from us one way or another. Of course, we also have a fair amount of forecasting. We have a big supply chain worldwide, as you can imagine. Right now, it's a bit disrupted, and people need to know that sort of thing. Also, like on the demand side, how many products do we need to produce? What will be of interest to the consumers as well, right? Before we start producing. We also have things like geospatial analysis. I can show a bit more, on that together with computer vision on the next slide. Okay. So, in terms of computer vision, we do run a fair amount of deep learning analysis like this. In this case, here up on the left, that's like an example of age verification. So as you know, we don't sell things to minors. We don't want to sell things to minors. So we're also using image to make sure that people actually are, appropriate age. A bit similar to this, but with a bit different focus. We also analyze pictures that people share. I'm sorry. Here we go.
Keyboard.
Sorry?
Depends on the keyboard.
Yeah. I have fast trigger fingers. Right. So, yeah. So, in this case, for example, we start doing analysis of what kind of colors do people actually use in association with other products. In this case, like someone is taking a picture of their Starbucks coffee together with their device. Try to understand a bit more on the sort of association patterns, and see if we can find future partnerships. For manufacturing, or actually leaf prediction in this particular case, we're also doing analysis of satellite geometry. And we're using this to see ahead of time if we're going to have an issue with the crop yield. Ultimately, we are a company of hiking farmers. So, yeah. So, let's get to the summary. So, one of the things I want you to take home is that it's very hard to scale a centralized team especially if you're a big company. So instead of trying to do that, because I think it's a bit a fool's errand, give the subject matter experts access to the tools so they can do the analysis themselves. And then just try to support them wherever you're needed. Instead of trying to control everything yourself. However, you end up in a new kind of problem if you do it. Like this decentralization is that you start duplicating efforts. Different teams do the same thing, and it's become actually quite expensive. It can be quite chaotic. And for this reason, that's why you really need to have a center of excellence to sort of steer this a bit, to define a bit what does good look like. My recipe for how to become a natural partner for the spokes is, you need to first of all offer them, a really good analytics platform, because that brings them to us. As you can see, it's been very, very effective for the slide. We're growing at a very high speed. We also need to provide people access to the data, because having a good compute platform with no data, it's of no use. And then also we need to make sure that we have the best people that we can find in the Center of Excellence, because I want the Center of Excellence really to lead by example. Then, last but not least, to echo a bit what Leandro was saying, document and automate, streamline, and also measure really everything. It's really important, and it's a bit of an overhead, but it pays back in the long run. So I think we are done.
Yeah. Thank you for this last sentence.
We have time for questions.
At least 15 minutes.
The multi-GPU setup that works along with the system.
Yes, basically for this what we use is this service from AWS that is AWS SageMaker, and basically we from the platform team provide the data scientists the capabilities to just go ahead and spin it. Maybe Dinesh can go a little bit with what it does.
Yeah, basically it's a native part of the SageMaker. So if you have a training workload that needs to run on a distributed setup, so you could scale using the SDK. So for instance, I don't know if you're using maybe a G4 instance, perhaps you could run the same training job on maybe 6 or 20 of those GPUs.
So I will ask a question regarding the teams. So if I understood your setup correctly, you are a very large organization with many people who want to work with data and do some prototyping of this. And at some point you realize that you need a unified way to give this access, and you build this DS Lite, and your job was to kind of sell it internally, right? To convince more data scientists to use the tools. And when you say that you had a chart with the number of users growing,
Yes.
these are not new hires, right? These are internal.
Primarily, it is all these little sort of shadow IT groups everywhere in the organization, right? That some of them, they don't call themselves data scientists. Some of them call themselves statisticians,
Sure.
or econometrics, these kind of people. But they have one thing in common, often, is that often they run things in a electrical lab on their laptop. And they have a problem with how can I go into production with this? How can I automate everything? And that's usually when they come to us and say, hey, actually, you have a platform, you're already doing this, can you help us out of it? So I wouldn't say that our job is to sell it. It's more like we created something that was good for us.
Mm-hmm.
But then you realize that this is so good that it shouldn't be our secret. rather than us trying to use this as our secret sauce to be the most efficient, in the company, we give open access to everyone who wants to use it.
I see. So, and probably you, at some point, you want to reach a milestone where like everyone in the company who is doing data science will be on DS-Lite, right?
Hopefully, yes, that's kind of the end.
I see.
But we don't force anyone.
Yeah, definitely.
So yeah.
Okay. And maybe one more question. So if one of those teams, you mentioned about monitoring, and I really like that part. So in my previous life, I was working in industry, and we didn't have that part very well defined. It was causing a lot of problems. So my question is like, if one of the teams starts to use like SageMaker on 4 GPUs and forgets to turn it off, like how long it will take you to see and warn that guys like we are paying AWS $5 an hour for nothing?
This is a very interesting question because being like having this kind of centrally monitored, it's hard to actually differentiate who forgot the machine running from those that actually are working with stuff. Maybe not happening that much with SageMaker for the use case that we have, because basically it's like shoot and wait. So till it's done, it's just gone. But we do have this problem, for example, with EMR clusters. We are providing like long-running EMR clusters, and maybe someone provides a super big one and completely forgets. So we have this kind of monitoring, these metrics, and honestly, we don't have that kind of alarming yet, but it's kind of a conscious effort from my platform team that it's looking at the charts, and when there's some blip that goes around, just go knock it on. Hey, what are you doing?
We have these charts that you can actually go and see how much did I use, last hour, last 30 days, etc. And especially like in workspaces, they have your username attached to it. So sometimes you discover that, maybe that one I should have shut down, right? But I think we still not have a notification,
Not there, it's a kind of manual effort for now, but it's coming, it's on the works for sure.
It's okay at this step. I mean, manually, if you have a dedicated team to do these things, someone will notice it one day by itself, right?
Part of the, just to add to that, so part of the monitoring is also to provide visibility to the users on where and how you're consuming the resources. So you also have the chance to optimize. So, I mean, instance, if you're deploying an API or if you're deploying a workflow, so you got to see, okay, so what is my incoming load versus, okay, so am I over provisioning? So that you could, tweak something while you're still in the development and then move to the production. So, to your question, maybe not on the SageMaker, maybe like we also have like certain other protections like auto scheduling, so auto terminations of the clusters. So let's say we make it easier to extend the lifetime of the infrastructure, but then it could get killed by default after a certain time. So if you have the need for continued use of infrastructure, it's easy to extend the lifetime. But let's say if you're unattentive and if you're not really using it, so there are some checks and balances.
Yeah, mechanisms to
and also when I'm allowing everyone to start creating labs without me, doing it for them, I'm also tracking who actually created it and what is their cost center. If that person decides to leave the company, at least I know someone who's, I talk to, really
accountable.
You need to keep it alive, Can I kill it?
Yes. I have one more relatively technical question. I saw you use Seldom Core. I assume you use it for deployment. But I was curious. I know SageMaker also has quite famous deployment.
Other SageMaker endpoints.
You use SageMaker for some, but you don't use it for
This was kind of an internal struggle. We had data scientists that were coming and asking for this kind of SageMaker endpoints, but there is a cost related to these SageMaker endpoints, and you kind of need the SageMaker running for servicing these kind of endpoints. So it kind of defeats this usage that we have for SageMaker of not having it running indefinitely. When we say no, you cannot use the endpoint, they say, oh, what do I do? So this is why we provide Seldom for them to be able to.
And also to leverage on other capabilities of Seldom, because it has some nifty components for drift detection, so like which really works nice with not only tabular data but also like images and text and so on. So just to have that full control on the end-to-end MLOps pipeline and also to optimize costs.
Yeah, I have a question more about like business outputs. Do you compare this approach with the previous one in terms of like time to market, time prototyping, infrastructure costs, is it better or not? And maybe you can share some results.
Yeah, so in terms of like time to market, I think especially in the past we were not really properly tracking it. So I think that's already part of the answer, right? If you're not tracking it, you're not going to do a very good job at it. So yes, we are starting to track it now. In terms of like output, some of the hardest things is when spokes they do something on their end, but we don't really know what they are doing. It's hard for us to know the actual business value. The only way we can sort of find out is to actually discuss with them. You know, this project that you did, you know, how did it turn out, right? So that I think is like a very good challenge. You know, like how can you? We've tried to automate everything, but that part is not automated.
Do we have more questions? I will ask one more about data storage types of things. So it's not the obligation of your teams to make decisions about where to store it.
Yeah, basically we don't have a representative of that team here with us today, but the whole idea is that we have this enterprise landing that is called in PMI, and that it's where all the data that is going to be then used in productive use case should be, and we consume from there. They do the ingestion, they do some quick transformation and provide consumable data, and then we go and consume for this. For quick data exploration with DSLine and these kind of things, we do have some mechanisms not to have to go the full circle, but yeah, for productive use cases, we have this data.
You know, my question is more about like cost effectiveness of data storage. Like in my experience, again, we were not as experienced as your team, so we were making mistakes in early design of the data storage, and we realized like on S3 we are spending more money than on compute, and then we started to restructure, like the number of files was growing exponentially. We decided to store them in a more efficient. So these kind of things are happening, like you could discover this on the fly, right? Maybe from the first time.
Yeah, so like I think the real answer is that we have separated storage from compute,
Okay.
and what we provide is like this compute platform.
Yeah, so there are other things. So.
And as you saw, like I have a link, you know, to our data management center of excellence, right? So ultimately, we have people who are like data management, data architecture, etc., data quality, and they are responsible for that part. No, of course, we have a lot of interactions with them, you know, because I've been driving, for example, we need to make it easier for the data scientists to discover what data is there, you know.
I see.
That sort of thing, right? But ultimately, it's their task.
Yeah, sure. And
So there are quite few layers also like Rikard was sharing. So data engineering, and also I mean if there is sensitive data, so all the data that comes in through automated ingestion pipelines also gets monitored for quality or like for sensitiveness. So it gets profiled sort of thing, right? So if you're dealing with really class A or sensitive data, so like certain additional constraints or security requirements apply on how you can treat it. So in terms of, I mean, to your answer on storage, yeah, I think it was covered. So.
And what is the relation? I think I missed that part. Like you said that you're moving towards the product-based structure of the company, right? So if there is one new product, for example, or maybe one team is split into two parts. So how this product vertical, I should say, starts to interact with you and the data management teams. You exist in all.
So we are actually at the beginning of this transformation towards a product-based organization. So it's not something that we're doing like rolling out the entire company
Sure.
at one go, right?
Yeah.
And then, yeah, there's also a bit of a matter of like how do we define a product, you know, because
Yeah.
it's a matter of how thin you need to slice it, right? But the basic idea is that all of these product teams, they should be self-sufficient. So if they have a need for analytics, they need to have like their own analytics team.
And that interacts with your star?
Yes.
Interesting. There was a question there.
Yeah. Do we have more questions?
Yeah, I
Honest,
just said, maybe you answered it in a way, but I was kind of curious. So I want to refer to that chart again of usage. So what's the process like in your in PMI? Is it you proactively go try to promote the DSLI, the platform you have built among other organizations, that organize meetups, etc. Like, what's the process like?
We are going there. This growth here, as you can see, that's just purely organic. It's just due to, I think we're becoming seen as like a natural partner to do this sort of things. But as you can see, especially from the blue curve, which is the folks which are not part of our organization. Now, we are also establishing like a community of practice. So we have like one person who's responsible as a community manager. He is going to organize like a big event soon. He's also responsible for other things like newsletters, you know, showcasing what's new, what are new features into the slides, you know. So he's like the primary point of contact for you know, all the users. You know, it's more like at least on the bottom-up approach, right? And the idea there is also that it's not just about we sort of sharing what we think are the best practices, but also to have like different teams come and present how they did things and they can learn from each other.
That from an internal point of view,
Yeah.
we also do external thing that this is what we're here showcasing, and also we are hiring if someone interested.
Yeah, we're out of time. Thanks for attending. And if you
talk
have
to
more
us.
questions, we are here. Yeah, please use the lunchtime efficiently and connect to more people. Thank you.